Now let's study metals and their compounds in this video. Now what are metals? You see, metals are elements that lose electron to form positive ions. For example, if I have, look at this metal in the group 1 of the periodic table. Let's pick sodium, Na, which is sodium. Since it's a group 1 element, it loses one electron to form its own positive ion. If this guy loses one electron, what do we have? We have what we call what? Na+. Let's pick another element in group 2. Let's pick magnesium. Since it's a group 2 element, it loses 2 electrons to form its own positive ion. Then we have what? Mg2+. And let's pick group 3 element, aluminium. It loses 3 electrons to form positive ion Al3+. You can see these are metals. They lose electron to form what? Positive ion. Hence, these metals are electropositive. They are electropositive. They tend to give out electron. They don't attract. They tend to what? Give out electron. And you can see they always form what? Positive ions. This is how you know what? This is how you know metals. Non-metals, you see them having what? Negative ion. You see this positive ion, we call it some names. We call them what? Cations. Okay? Positive ions here are called what? They are called cations. Good. Now take note of something, that metals have what we call mobile electron in their structure. They have what we call what? Mobile electron. They have mobile electron. You see, the word mobile means that the electron is delocalized. Another word for mobile is called what? Delocalized. It means that what? This electron can move about in the structure. Because they have mobile electron, metals are able to conduct what? Heat and electricity. Okay? Metals, they are what? Good conductors of heat and electricity. Are we together? Why can they conduct electricity? Because of the presence of mobile electron. Good. Also, if you look at metals, they are what? Malleable. They are malleable. Also, they are what? Ductile. You see, malleable means that, malleability means that if they can be hammered, it means that they can be hammered into sheets. Okay, they can be hammered into what? Into sheets. That's the meaning of what? Malleable. And what meaning of ductile? They can be drawn into what? Into wire. Are we together? They can be what? Drawn into wire. Good. Now the next one is this, is that what? They are shining. They have this kind of shiny structure. You see this shiny structure, we call it a name. What's that name we call it? We call it what? Luster. They have this or this ability called luster. Are we together? Good. Also, take note of something, that what? This property that we are listing about metals, it is not all the metals that have it. Let me give us an example. Everybody take note of something. There's a particular metal we call mercury. We call that metal mercury. The symbol is Hg. You see, mercury is a metal that is liquid at room temperature. It is a liquid metal. Are we together? So mercury is excluded from this property. It cannot be hammered into sheets or drawn into wire. So mercury is not malleable. Also, it is not what? Ductile. Are we together? Exactly. Okay. Also, some metals are sonorous. There's something we call what? Sonorous. It means that when you hit them, they produce sound. That is why you see that what? Metal is used to make bell. Because you know, when you hit it, it produces this kind of sound. That's the name of the word what? Sonorous. I can say that some metals are actually used to produce musical instruments, and the strings of musical instruments and so on like that. So that is that about that. So these are the physical properties of metals. Next, let's look at the chemical property. In our previous lesson, we discussed the physical properties of metals. Now pay attention that you will notice that, you see, some metals are hard while some are soft. Why is it like that? Pay attention that, you see, looking at what we call the metallic bonds, looking at what we call what? The metallic bonds of metals. Look at this following metal, Na+ and Al3+. You see this +1 electron you are seeing here means that in the structure of sodium, sodium only donates 1 electron into the electron cloud. to carry out metallic bonding, while aluminium donated 3 electrons into the electron cloud to form what we call this metallic bond. Now, if I ask you which one will be the strongest, sodium or aluminium? Sodium donated just 1 electron into the electron cloud to form metallic bond, while aluminium donated 3 electrons into the electron cloud to undergo the metallic bond, which means that aluminium will be harder than sodium. And that is why you see sodium and potassium, you can cut them with a knife. They are so soft because they just donated 1 electron into the electron cloud for their metallic bond. But aluminium is stronger. You can't cut it with a knife because it was donated more electron into the electron cloud. So take note of that. Now let us now go to their chemical property. You see, because of the fact that metals can give out electron, it makes them good reducing agents. Good what? Reducing what? Reducing agents. We call them what? Good reducing agents. For example, now check sodium. When it becomes ion, what happens? We have 1 electron. So metals can readily give out this electron, and that made them what? And that made them what we call reducing agents. Are we together? Metals are reducing agents because they readily donate their valence electron. Are we together? Good. That's for that on what? On metals. Also, if you look at metals, you see they can react with acid to produce hydrogen gas. For example, look at this metal, Mg. This is a metal, magnesium, plus water, plus acid, sorry, HCl. This will give me MgCl2 plus H2. If you look at this, you observe that what? A gas is being given off. Whenever metals react with acid, a gas is being given off. And how do we know this hydrogen gas? It is a gas that gives pop sound with a lighted splint. When you put a fire, like a flame, close to hydrogen gas, it gives this kind of pop sound. Good. So when metals react with acid, there's effervescence or evolution of hydrogen gas. Are we together? Take note of that. Also, if you look at metals, metals form what we call basic oxide. Metals form what we call what? Basic oxides. Yes. They react with oxygen to form what? Basic oxide. For example, magnesium plus oxygen will give me what? MgO. Are we together? Look at it. MgO. This is a what? This is a basic oxide. Are we together? Good. Now, metals react with oxygen to give us basic oxide. Now, look at these metals. There are some metals like lead, tin, aluminium, zinc. You see these metals here? They form a kind of oxide called amphoteric oxide. Called what? Amphoteric oxide. These are kind of oxide that can behave as an acid and also as a base. Next property of metal is this. Remember we said they form basic oxides. These are bases. But some of them, e.g., lead, tin, aluminium and zinc, they form amphoteric oxide. Amphoteric oxide can behave as an acid and also as a base. These are, you see, metals form basic oxide. But what about non-metals? What do non-metals do? Non-metals form what we call what? Acidic oxide. Let me write it for you. Non-metals form what we call what? Acidic oxide. Acidic what? Oxides. So what are those examples? SO2, SO3, CO2. All these are acidic oxide. They are what? Oxides of what? Non-metals. So good. Oxide of metal are called basic oxide. And some of them can form amphoteric oxide. While oxide of non-metal, they are called what? Acidic oxide. They call them acidic oxide because they react with water to produce acid. They are not acid, but they are acidic. What does that mean? They react with water to produce what? Acid. Are we together? Good. Next one is that you see metals, they can react with water. Let me give you an example. For example, sodium can react with water, H2O, to give us an alkalis, then with hydrogen gas. We give us what? Alkalis, then hydrogen what? Hydrogen gas. But take note of something. You see sodium and potassium, they react violently with water. Like this reaction is very violent. Violent reaction, yeah. In a way that you are not advised to try it. They react what violently with water, sodium and potassium. Why some other metals, you see, some other metals react moderately with water. Let me give you an example. You see, sodium and potassium, they can react with what? They can react with cold water. We always react them with what? With cold water. All together? Good. Also potassium, they can react with what? Calcium rather, they can react with what? Cold water. All this. Why are we reacting them with cold water? They are reactive. Good. So we have to use cold water. Why moderately reactive one like magnesium, are you there? Aluminium, zinc, are you there? Iron, all this we react with what? With steam. All together with steam. Why other less reactive metal like lead, silver, gold, all those ones don't react with water at all? Okay, good. So all these ones, they are very reactive metal. Why this part? They are what? Moderately reactive what? Metals. Okay, moderately reactive metal. So these are the what? These are the properties of what? Of metals. So take note of them and let's go to the next episode. Now, let's look at the next concept. The next concept is the activity series and electrochemical series of metals. Now, I've jotted some important points for us here, and please pay attention for you to get this concept clearly. Now, look at this. I've sectioned metals into three groups. The first group are the very reactive metal. The second group are the moderately reactive metal. And the third group are the least reactive metals. Are we together? Good. Also, there's another column here representing their what? Electropotential, the standard electropotential. You see that the electrode potential of metals above hydrogen are negative, while the standard electropotential of hydrogen itself is 0.00 volts. While metals below hydrogen have positive standard electrode potential. Now pay attention to this concept very well. You see this very reactive metal, how can they be extracted? You see what you want to learn here also, you learn their principle of extraction. Principle of what? Extraction. That is, how do we extract a very reactive metal? Now look at this set of metals that are very reactive. They are extracted by electrolysis. They are extracted by what? Electrolysis. Highly reactive metal are extracted by what? Electrolysis. It could be electrolysis of their chlorides and so on like that. So that is how they are extracted. Why? Because they are very reactive. You can never find them free in nature. It's not possible. You can either find them as oxides, are we there, or as chlorides and so on like that. You always see them in combined form because they are very reactive. They cannot be free. Next, we have the moderately reactive metals. You see, all these ones, they can be what? They can be manufactured or they can be extracted by reduction. By reduction of their oxide or roasting their oxide or trioxocarbonate. So, in short, by reduction or by roasting. Okay? It could be reduction of their oxide, or it could be what? Roasting of their trioxocarbonate or their sulfides. So in the short form, they are extracted by reduction. That reduction can be done with a reducing agent like coke. Are we together? Good. That is that for that. Now, remember that what? Hydrogen itself is not a metal, but it is just placed within metal because it has some characteristics with them. So we are skipping hydrogen. Now the next one are the least reactive metal. Now, because they are least reactive, they can be found free in nature. Altogether, they can be what? They can be found free in nature. So all these are free elements. They can be found free in uncombined states. So in summary, the principle of extraction of metals is that highly reactive metals are extracted by electrolysis. It could be electrolysis of their oxides or their what? Or their chlorides. They cannot be found free in nature because they are highly reactive. Next one is the moderately reactive metals. Here they can be extracted by what? By reduction with reducing agent like coke. Also, they can be extracted by what? By roasting. It can be roasting of their oxides, or roasting of their sulfides, or roasting of their trioxocarbonates. Next are the least reactive metals. All these one can be found free in nature. Okay, good. If you observe this column for the standard electrode potential, you will see that the standard electrode potential of metals above hydrogen are negative. This means that you see this negative standard electrode potential means that you see this element, they can easily lose electron. Are you together? They can easily lose electron, and they are strong reducing agents. Strong what? Strong reducing agents. Metals above hydrogen have negative standard electrode potential, and they are strong reducing agents because they can easily just give out their electron. While metals below hydrogen have positive standard electrode potential, all this one they are less reducing. Altogether, they are less, or they are weak reducing agents altogether, and they do not give out their electron easily. Okay, they are weak reducing agents, and they don't give out what their electron what freely like that. So that's that. Also, let me add this to it. You see, if we want to make coin, let me say in coinage, which is the best choice to use to make coin? Is it so we're explaining that of the coinage, that which one is the best choice in making coins or medals is the least reactive ones. They are least reactive, that's why we can use them to make medals or coins. If you use the very reactive one, they will react. Okay, so that's that. Now in summary, we've learned that highly reactive metals are always extracted by electrolysis, while moderately reactive metal are extracted by reduction. You see, the reduction is of two types. We have what we call chemical reduction. That is, we can reduce them by using chemical substances like coke. While we have the other type of reduction, which is the thermal reduction, that is making use of what? Heat rather. Making use of what? Heat. That is when you are roasting their sulfides, their oxides, or their trioxocarbonates. Good. Highly reactive metal extracted by electrolysis. Moderately reactive metal are extracted by reduction. It could be chemical reduction, making use of chemical substances like coke, or thermal reduction, making use of what? Heat. We deal with what? Roasting their oxides, or roasting their sulfides, or their trioxocarbonates. Why least reactive metal are found free in nature. Those metals above hydrogen have negative standard electrode potential, while those one below hydrogen have positive standard electrode potential. While that of hydrogen is what? 0.00 volts. Okay, good. So this is where we end the episode 1 of metals and their compounds. Do well to share this video, like, comment, and subscribe to this channel so you get notified when I release any new video. Thanks for watching.